Hello everyone, welcome to Module 13 of Climate Change course. In this module, you will be introduced about hydroelectric power, which is another type of renewable energy resource that are widely used as an alternative energy supply in many parts of the world and also bring about many controversies regarding its negative impact on the environment and social system. So in general, in this module, we will cover 3 topics, including the history of hydropower, type of hydropower plant, and also the associated environmental and social impact of hydropower project. So by the end of this module, you should be able to explain in general about hydropower resource, as well as describe different type of hydropower plant along with the associated socio-environmental impact of hydropower project. Hydropower is a kind of renewable energy resource where power is derived from the energy of moving water, either in the form of mechanical energy or electricity. So from the history, the mechanical power of falling water have been used since 1,000 years ago for very simple application. For example, to turn the pedal wheel to grind grain, flour, and other food products. However, the hydroelectric power was only available in the late 1880s, when the scientists had figured out how to produce electricity using the mechanical power of moving water. Then the first hydroelectric power in the world was built in the United States in 1882, with the installed capacity of only 12.5 kilowatt. And it was after that time that the hydropower project started to emerge also in other parts of the world. Basically, when we talk about the hydropower, we refer to the hydroelectric power, which is generated from kinetic energy or moving water. The process of deriving hydroelectric power is first a strong water current, in most cases, water that moves from higher to lower elevation such as waterfall, push the turbine to rotate to convert the kinetic energy in the moving water into the mechanical energy. Then such a mechanical energy is converted into the electricity by an electric generator. And finally, the produced electric power is transferred to the electricity grid and distributed to the end user. So because the process of generating electricity from moving water requires a strong water current or movement to drive the turbine, hydropower plant must compose of a moving water unit and are generally located near the source of moving water, which include river, stream, water cascade, and also fall, that can provide a year-round water supply capacity. Furthermore, to ensure the continued production, especially during dry season, dams and reservoirs may also needed to be constructed on the water course of water source. Basically, hydropower plants come in 3 types of design, including run-of-river, storage, and pump storage type. The run-of-river hydropower plant generally have a small intake basin with no storage capacity, which means that there is no regulation on water flow. So for this type of hydropower plant, electric generation process vary with water availability change. Then the storage hydropower plant is the hydropower plant that connected with a reservoir that can be natural reservoir or man-made, which can deliver a broad range of energy service such as a base load, peak and energy storage, and act as a regulator to ensure continuous production even during the low flow season. In addition, the storage type hydropower plant also delivers services that go beyond the energy sector, including, for example, flood control, water supply, navigation, tourism, and also irrigation services. Then the pump storage, on the other hand, is a more regulated type. It connected with the natural storage and a pump, which allow full control of water flow. So for this type of hydropower plant, electrical energy can be produced anytime on demand. In addition to what we just talked a while ago, hydropower plant may also be classified according to other factors, such as the installed capacity, the presence of reservoir, and also the height of headwater. So for instance, by installed capacity, it can be classified into 4 types. ranging from the micro to the large installed capacity hydropower plant. Then by the presence of reservoir, it can be divided into the hydropower plant with or without reservoir. Similarly, by the condition of headwater, the hydropower plant may be classified as high head or low head according to the different height of falling water that is used to drive the turbine. Okay, now so move on to the advantage of hydropower project. Just like other type of renewable energy resource, hydropower offers a wide range of advantages both for climate change mitigation and for human development. This slide presents some common advantage of hydropower project on the socio-economic development. So as you can see here, the more common benefit offered by hydropower projects on our livelihood include the provision of clean and renewable energy, which is an alternative choice of energy supply for both domestic and commercial use, as well as providing recreational opportunity, water supply, and flood control services. Then in terms of the environmental protection and climate change mitigation, hydropower project is also a potential measure to help improving the quality of our environment and to mitigate greenhouse gas emissions. So basically, this is because hydropower is a highly efficient energy production process. It can convert about 95% of kinetic energy in the moving water into electricity, and it does not emit any greenhouse gas into the atmosphere, nor release any type of pollutant into the environment. So earlier, we learned that the hydropower project provide many benefits, both for the environment and for our socio-economic development. However, you also probably heard about various controversies regarding the negative impact of hydropower projects on the ecosystem, the surrounding community, as well as some transboundary socio-political issues. So basically, all types of energy sources bring about some negative impact on the environment and also social system, and there is no exception for hydropower project. So on the environmental side, hydropower project bring about various concerns to the natural environment, ecosystem of the project area, and its neighborhood. For instance, the construction and presence of hydroelectric dam can induce a change in water flow and sediment transport, which in turn negatively affect the water quality and ecosystem of the river and stream by causing disruption of the ecological continuity and fish migration. However, the extent to which a river physical and ecosystem characteristics are affected depend largely on the type of hydropower plant as well as the operational plan. In addition, large-scale hydropower operation can also cause variation in the regional water cycle, which can potentially affect rainfall pattern in the region and consequently resulting in unexpected flood and drought that can lead to further negative impact related to land use change and preservation, as well as ecological damage of the affected area. And aside from that, the presence of hydropower projects also put the downstream population at risk of dam collapse, which may result in a disastrous situation. So let's move on to the impact on the social system. Hydropower project can affect the society, especially the local and regional community, in many ways, both directly and indirectly. In general, the impact could exist in all project development stage, from construction to operation and closure, though the severity of the impact can vary depending on project type and site-specific condition. But overall, for every hydropower project, most common social impact include change in land use, health risk and safety concern, habitat loss, economic loss, as well as cultural damage. In particular, the creation of a reservoir for a large hydropower project in a densely populated area can entail significant challenge that related to resettlement, land use change, along with other livelihood concerns, especially for people who live in the downstream region. Then in some cases, development of large hydropower projects can also put a country into socio-political instability situation, as well as provoke political tension between the neighboring countries. For example, The development of Sayaburi Dam on the mainstream of Mekong River portion in Laos have brought about many socio-political concern and debate over its negative influence on the ecosystem and socio-economic development of the downstream population. The tension happened not only inside Laos, but also inside and between other Mekong countries, which include downstream countries such as Cambodia and Vietnam. In addition to what we have discussed earlier, the negative impact of the hydropower plant project on social system could also extend to a disaster level, particularly in the case of dam collapse incident, although such an incident does not happen very often. So, for example, the incident of the Sepen Senam Noi Dam in Laos have provoked severe damage both to the environment and social system of the downstream community. So basically, the project was started in 2013 with a plan to begin the operation in October 2019. Unfortunately, the incident occurred in July 2018 while it is still under the construction stage. This incident caused a rapid inundation in 6 downstream villages and severe flooding in other 13 villages, resulting in 13 deaths, 100 are missing, and approximately 7,000 of people lost their household and livelihood resource. So now we have reached the end of today's lecture. I hope you have learned all important points given in this module, particularly the issue associated with hydropower, which include its benefit for the environment, climate change mitigation, and socio-economic development, as well as its negative influence on the socio-environmental system. So let's call it a day and good luck for your final exam.